welcome everyone to this 5th webinar in the series of the national initiatives. Webinars that are organized and moderated by the SNS Co-op Support Action. My name is Uwe Herzog. I'm with Eurescom and I have the pleasure of moderating through the webinar today. We've already had webinars on the UK, Netherlands, Italy and France to present their initiatives. And today we give the stage to the Swedish National Initiative on 6G. The goal of the webinars is to give the floor to the national initiatives to share their achievements and highlight their key results so far, and also to position themselves strongly in the European research ecosystem. And for opening the webinar today, I'd like to give the floor to Raffaele De Pepe, who is a Vice Chairman of the 6GIA board. Raffaele, floor is yours.
Yeah, thank you, Uwe. Hello, good morning to everyone. Good afternoon to everyone. I'm connected here from Rome. Today, I'm speaking on behalf of 6GIA board, which I'm representing here today. So as you may know, 6GIA is the private association representing the private industry in front of the European Commission in a joint public-private partnership called SNS JU, so Smart Networks and Services Joint Undertaking. This is a new private-public partnership between Europe and industry, in which the industry is more in a driving seat of the research for 6G in Europe. At present, we have more than 430 members. So these members are mainly private members coming from the big industries, from SMEs, but also from the research institutes, universities, and so on. I'm particularly glad today here to open this workshop with the Swedish Research Initiative on 6G. We believe that synergies between European-led research and national-led research are particularly important in order to have a very important footprint for 6G on part of Europe. So I just want to say you this welcome from the industry, from the 6GIA. Of course, Sweden is one of those countries in which mobile telecommunication was started 20 years ago, and I was there with the 2G, which was a success. So of course, what we want to do is to put the basis, solid basis for a 6G that will be important, not only for the mobile industry, but also for the Europe economic system and for European citizens. So welcome to everyone.
Thank you, Raffaele, for the kind welcome. So let's then move right into the presentations. And the first one will be on an introduction and gives an overview of the Swedish 6G initiatives. And this will be given by two people. First, we start with a presentation from Lars Gustafsson. So Lars, the floor is yours. Lars, we are still muted. We can't hear you yet. Lars, you are still muted.
Okay, now.
Now, yes. Thank you.
All right. Can you see the presentation?
Yes.
The PDF? No,
Yes.
You can't.
All fine, yes.
Oh, you can see it?
Yes.
Great. Okay, thank you very much. So I am Lars Gustafsson, is the Swedish representative in SNS JU State Representative Group. And I have the pleasure to make a short introduction to 6G initiatives in Sweden. So I come from Vinnova, which is the Swedish Innovation Agency. If there is one word to summarize what we're doing, it is about sustainability, both sustainability for society as well as for business. And the Vinnova agency work mainly in 4 areas of innovation. So when it comes to digital transformation, the main feature that we're going to present today during this webinar is Advanced Digitalisation, which is a large national initiative that Vinnova has together with Swedish industry stakeholders and research. And the role of Vinnova is to identify, to mobilize, and fund. So we do a lot more than provide national funding for collaborative research, a lot of mobilization. Come back to that later. And international cooperation is, of course, crucial for a sustainable future. And for Vinnova, it means that we are represented in a number of regions. So we do have a Brussels office. We have an office in Stanford, so that is Silicon Valley, where we have joint activities with the other Nordic countries. And then we have partners such as Swedish embassies around the world. We are the Swedish link to EU funding. And one aspect of that is that Vinnova is coordinating the activities within not only ourselves, but with other agencies when it comes to EU, the EU research programs. So like the national contact points, we have a special task there from the government to coordinate the Swedish activities. Now, when it comes to funding, we are not only the only agency or source for funding in 6G. First, I would like to point out that the universities, they have their own budget. So, of course, they initiate activities for not only higher education, but also for research. We have the Swedish Research Council, which, to simplify it, fund universities and individual researchers, amongst other areas in 6G. We have SSF. They have interesting ongoing funding and initiative in the area of space communication. So there are other public actors in the field of 6G than Vinnova. And I just want to point out that when it comes to activities and funding in the area of connectivity and 6G, it is, of course, like in other countries, the companies that makes the most, let's say, short-term impact. So Sweden is well known in this area for Ericsson and some telecom operators, but there are initiatives where different verticals are working together for new type of services and new technologies. And Advanced Digitalisation is a very good example of such an initiative. So when it comes to programs, Avancerad Digitalisering, that is Advanced Digitalisation. Elena will explain more about that in a moment. There are national programs for startups. We also have a network of incubators in Sweden. And we're also involved in Eureka and Eurostars. When it comes to excellent centers, there are a number of ongoing initiatives, and we will hear more about 2 of these today later in this session. And then we have an assignment from the Swedish government to run a 6G initiative, 6G program. And we share that with the Swedish Research Council. One future initiative is clusters of excellence. This is a new initiative. It started in 2025, and it's a big one. The designated areas are these, and then if you look at the first two ones, artificial intelligence, autonomous systems, and the second one, advanced digital technology, including semiconductors, of course, connectivity and 6G is obviously in those areas. And this is another assignment between Vinnova and the Swedish Research Council from the government. It's a big program. It has just started, and we have assigned a number of pre-projects to start to be operational by now. And the goal is to gradually build up at least 5 clusters of excellence to be well known worldwide by 2035. So this is new. And that was my introduction. And over to Sverker.
Thank you. Yeah, please, Sverker. Floor is yours.
Okay. Thank you. So can you see
Yes,
the screen now?
all fine, yeah.
So good afternoon, everyone. My name is Sverker Brundin, and I'm the manager of Sweden's 6G program that Lars talked about. So I'll give an overview of this government-backed effort to strengthen global leadership in wireless systems and connectivity. Why and what? Well, in March 2024, Vinnova and the Swedish Research Council received separate assignments from the government to strengthen Sweden's global leadership in wireless systems and connectivity research. In total, 390 million Swedish crowns, about 36 million euros is used for this. And Vinnova's goals are among what you see here: innovation, competitiveness, and collaboration. Vinnova's part in the 6G government assignment, we have currently 79 projects funded. We have divided the funding into different categories: research and innovation, international collaboration, skills and competence, and development synergies between technology areas. And the largest share of the actors are universities, followed by private companies, research companies, and a small part is publicly owned companies. And in the part that is research and innovation, we have funded to this date 129 million Swedish crowns. And among the actors, we find all the leading universities in Sweden and many abroad, also research institutes and big companies like Ericsson and Google. And there are several small companies and startups in the projects. And in the international projects, we have collaboration with partners from the USA, UK, Germany, South Korea, India, and more. This map is a very rough text clustering of the projects in the portfolio. So within future challenges and opportunities in 6G networks, we find many projects around edge and AI technologies. We have lots around sustainability, focusing on, for instance, energy efficiency, heat recovery, load balancing, power distribution, and we have within future development of 6G, We fund projects related to distributed MIMO, ISAC, linearization, testing techniques. And we have quite a lot of projects within antenna systems for millimeter wave applications. So I think that will be all for me.
Thank you very much, Sverker. So with that, we can then move on with the next presentation, which will be given by Lena Bäcklund, and she will give an overview of the Advanced Digitalisation program.
Okay, can you hear me and can you see the screen?
Yes, all fine.
Okay, great. Okay, hello everyone, and thanks for joining today. And first, I would like to thank you, Vinnova and the SNS, for giving us this opportunity to present the Swedish Research and Innovation Program, Advanced Digitalisation. And my name is Lena Bäcklund, and I work as process manager within the program. And I will start with a short introduction of the program, what it is and why it exists and what we have achieved so far. And then I will move on to one of our key focus areas, digital infrastructure and communication. And finally, we will take a closer look at 3 initiatives funded by the program that all are contributing to the progress towards 6G. Okay, so the program Advanced Digitalisation is built on a strong partnership between Swedish industry and the state. And together we aim to strengthen competitiveness and support a sustainable transition and promote security in a rapidly changing world. And this partnership is a joint and long-term commitment to collaborate and take on the challenges together. And importantly, we share both the opportunities and the risks, with every initiative co-financed 50-50 between industry and the public. And I understand this setup is in line with the model used by SNS joint undertaking as well. And our vision is that Sweden will continue to be a leading nation in innovation and research. And through combined efforts, we want to see next generation digital solutions developed at a much faster pace. And we focus on real relevant challenges and industrial needs and use them as a starting point to create synergies within and across sectors. So what we invest in today is meant to strengthen both our industry and our future capacity for innovation. And the program started in 2021. And in March 2023, the Swedish government committed 2.3 billion Swedish crowns to advanced digitalization up to 2027. And that means about 200 million euro. And in 2024, the funding was further expanded, and also adding the contribution on a one-to-one basis from the industry, the yearly budget coming years is at least 100 million euro. And the ambition is to continue all the way to 2031, and the impact of the program is meant to last long after that. So this scale and long-term perspective are what make advanced digitalization one of the largest and the most strategic research and innovation efforts in Sweden. Yes, and I want to emphasize that advanced digitalization is truly industry-driven, and that means the needs and the priorities of Swedish industry are at the very core of what we do. And practically, this means the program focuses on real-world use cases and challenges, whether it's digitalizing manufacturing processes or enabling smart transportation or enhancing cybersecurity in industrial systems. And not least, in this context, making sure communication systems of tomorrow are developed to fulfill future industrial needs. And by being needs-based, we ensure the research and innovation projects we support will have immediate relevance and uptake in the industry. And this also creates buy-in that companies are co-financed and actively participating because the outcome matters directly to them. And we also have a strong governance structure that keeps the industry in the driver's seat. And the program's board includes leaders from Ericsson and Saab, Tetra Pak, and we have Volvo Group, and the startup ecosystem with Swedish incubators and science parks, the industry association for Swedish tech sector, Teknikföretagen, and Vinnova, the Sweden's innovation agency. And our activities are centered around 4 interconnected pillars of activity. And the first is applied research and innovation, where we fund collaborative projects addressing industrial challenges, typically through open competitive calls, and then doing this together with Vinnova. And the second is open test and demonstration environments, giving companies and researchers access to real-life conditions to test new digital technologies. The third pillar is learning and competence development to strengthen skills and build future talents. And the fourth is dialogue and collaboration, making the program itself a meeting place for sharing knowledge and aligning national efforts. And these 4 areas are deeply connected, and together they make the program much stronger than any single initiative would be. And some stats, given the broad scope, since the start, the program has funded around 380 projects, and involving in total over 800 unique actors. And in average, project consortium has around 5 actors in average then. So this means both large industrial companies and SMEs, universities, institutes, and public organizations are involved. And in total, more than 410 million euro has been invested so far. And of this, about 100 million euro has been invested within the area digital infrastructure and communication. Okay, and given the broad scope of advanced digitalization, the program has identified a set of strategic focus areas to channel our efforts. And based on input from industry, we have prioritized a number of key themes for 2026 that you can see in this list. And I won't go through all of them, but before we narrow into the digital infrastructure area, I just want to mention the last one, international collaboration. So although this program is a Swedish initiative, we see international collaboration as essential. And many of our projects already work in international context, and this is something we aim to strengthen further to link our work with European and global research efforts even more. But let's now take a closer look at the key focus area, digital infrastructure and communication. We see digital infrastructure as a cross-cutting enabler that makes innovation possible in many other sectors. So like connectivity and cloud infrastructure and secure data exchange are not goals in themselves. They are tools that make industries more efficient and resilient and sustainable. For example, new communication capabilities can transform production lines and mining operations and logistic chains. And to make sure our work in this area stays relevant, we have a dedicated program council for digital infrastructure and communication. And this program council is led by industry and includes Ericsson and Telia and the industrial users such as Boliden, Atlas Copco, and Scania, and also representatives from academia and research institutes. And the role of the program council is to identify the most pressing industry needs within the area. So our industry partners have identified several key challenges that we are now addressing. And first, we need to remove the barriers that hold back industry from adopting the latest wireless technologies, such as 5G Advanced. And one way to address this is by supporting industry projects that demonstrate advanced industrial applications using these technologies. And second, the industry needs easier ways to test and validate new applications on the latest digital infrastructure. So we are now running pre-studies for a test center initiative that aims to give companies easy access to both test beds and expertise, also including then early 6G test beds. And the third, the infrastructure itself must, of course, be robust and secure by design and able to handle disruptions, and also having digital sovereignty in mind. And as data volumes grew rapidly, the need for AI training and simulations and data analysis increases significantly, and this is driving demand for new and innovative and optimized computing solutions. And finally, we need to prepare for early industrial applications of 6G and also satellite communication integrated with terrestrial network. And we see a need to involve the industry at an early stage to make sure the features fulfill what the industry asks for and that they are ready to test and implement as soon as possible. And in this context, we want to highlight also the importance of the deployment of 5G standalone today, both as a driver for digital transformation of industry today and also as a necessary step towards 6G. Okay. So now let's move from strategy and to action, and we will take a closer look at the 3 major 6G related initiatives funded by Advanced Digitalisation. First, the Sweden Competence Center, coordinated by the Royal Institute of Technology, and then YTech Competence Center, led by Chalmers University of Technology, and finally, we will hear about ISAC and Ericsson's sensing testbed that is partly financed via Advanced Digitalisation by a project that was initiated this summer. So I'm very pleased to introduce our speakers, Professor Emil Björnsson for Sweden and Professor Tommy Svensson for YTech, and then Dr. Peter Almers for ISAC. So thank you, and over to you, Emil.
Right, thank you. So my screen as soon as I can hear. All right, I guess you can see my screen now.
Yeah, all fine.
So SWIWIN stands for Swedish Wireless Innovation Network, and this is a competence center that is operating in the Stockholm region, and it is funded within this Advanced Digitalisation program through Vinnova, and that you've already heard about those type of things. So I will not introduce Vinnova and Advanced Digitalisation more, but rather you might be wondering, what is a competence center? So this is a type of long-term effort that Vinnova is having in different fields, which is particularly based on having academic and industry collaboration for a long period of time. So if everything goes well, we'll be running for 10 years, starting from 2024 up to 2033. And what are we doing in a center like this? Well, there are 3 different main aspects, I would say. It's the research part, it's a teaching part, and it's the outreach part. So when it comes to research, we are a number of different parties, and I will talk about them on the next slide, that are working together and that belongs to the center, and therefore we will be collaborating for a long period of time. And within the center, there is new funding that is creating the opportunity for basic long-term funding, and then the different partners from academia and industry is also using some of their own funding. So it's like a third from academia, third from industry, and third is a new funding that comes from Vinnova Advanced Digitalisation. But this is more creating like the base foundation for this collaboration. So the intention is also that we are working together both within the center and with different parties, for example, in Sweden, or also together in the EU project or so, to attract new grants. And we are already involved in some of the other funding activities that were described earlier today as well. So we have been successful already with some of those opportunities. When it comes to the teaching side, so we are working at the KTH Royal Institute of Technology in Stockholm, and we are teaching topics both for master and PhD students that are then hopefully going out in the Swedish industry and working afterwards. And we are taking in the knowledge that we are acquiring in such a competence center in order to improve our teaching programs and making sure that they are keeping up to date, and also organizing guest lectures where people come from the industry and inform the students of what's going on there. And of course, work a lot related to master degree projects and things like this. And then our third pillar is the outreach. So we are organizing a lot of workshops every year here in Stockholm. We have started an online seminar series just a few weeks ago, and I will come back to that later. And we also have the social media activities where we are writing about these different things as well. So, as was said, I'm Emil Björnsson. I'm both the director of the center and one of the active researchers, and I'm professor at KTH. And my research activities is usually the algorithms going on in this Ericsson base station here. So how it is being used for multi-user beamforming and stuff like that. But this center is not about me, but about a number of different parties. So we have KTH, and we have RISE, which is a research institute of Sweden. So this is also a public agency, but they are research institutes that are not doing teaching, but rather working with together with industry in different topics. Then we have three big companies: Ericsson, Saab, particularly the part of Saab working with radar systems, and ABB with connected factories. And then we have three smaller companies: Cellmax, Northern Waves, and Beamwave, all of them working with things related to antennas and radio hardware. And together, we are then gathering wireless expertise, starting from hardware to algorithms and protocols up to applications in a connected factory. So we are then dividing up our activities into these 6 different research areas. From the bottom of the protocol stack with radio electronics and antennas, Professor Oskak is the leader of that area. And I'm the leader of the physical layer network architecture area. Ishak Kavdar is leading the resource management and orchestration. We have an area related to resilience and security in these networks, led by Professor Mikael Skoglund. The learning and optimization, led by Carla Fischione. And the wireless functional safety, which is an application of when you would be replacing cables with wireless technology within factories. And it's Sibo Pang from ABB, who is also an adjunct professor at KTH, who are working in this field. So within each of these 6 different areas, different combination of the partners are working together. KTH is in all of them, RISE is in some of them, Ericsson is in all of them, Saab is in some places, and so on. So there is a base funding to work in these areas. And there is a platform to collaborate and an opportunity to work together also to bring in new funding. So when we were starting and writing an application for the center, we were looking for a vision. We knew that we wanted to gather people in the Stockholm region to work together more actively because we have seen the good outcomes of that in the past. But we were starting more from the perspective that we wanted to collaborate. And then we tried to figure out, okay, so what should be our vision of what we want to achieve? I mean, given that we already have gone through 5 generations of wireless technology, what are the research problems left to solve? And based on that, and also based on the fact that, 5G of today, the text is cut here at the top, but it says 5G is already fast. So here I was standing this summer in between the Ericsson building in Stockholm and measured the data speed to my normal iPhone here and reached like 1 gigabit per second in the downlink and 150 megabits in the uplink, latency of 10 milliseconds. So illustrating that 5G technology is already fast enough for most kind of applications that you might envision in the practice, in the best case scenarios. So it is not about anymore making technology faster, but it could be other metrics are important. And in general, the major societal challenge that we have is sustainability issue, that we are consuming much more resources every year in the world than we are able to do in order to have a sustainable world. So something like 1.5 globe of resources is what we have today. And at the same time, we look around in the world and we see that well, we would like to improve the living standards for people all around the world. And therefore, more efficient research utilization seems to be the key to achieve that. So we can actually use less resources while still improving the quality of life for people. And digital transformation seems to be the only way of reaching that. And when then people are talking about the digital transformation for new technology, collection of data, using Internet of Things devices to control different things, and maybe feed all this information into AI methods and automate things, then somewhere here in the middle, we have the wireless connectivity as an essential part to make all of these things to work. So that is what inspired us to build this center and think about what are the new kind of requirements that people in society will have on wireless technology in the future. And one of them is the availability. It should be there all the time, and people shouldn't even think about that it exists if we are successful. And we should no longer have this kind of rotating behaviors when our application is waiting for connectivity. We are also seeing that we are relying more and more on the existing wireless technology, and the trustworthiness of this technology then becomes increasingly important also in a world that becomes less secure than we were thinking that it would be in this decade. And then, of course, the ecological aspects, the greenness of the technology is going to be important. So if we in 5G have performance metrics like data rate, bandwidth, latency, and so on, then my example before was saying we have already reached very big numbers there. So whatever increases we would do in the 6G era in these numbers would probably not be very much noticeable to users. So we think that one should shift focus to new metrics and also new functionalities in the wireless network. For example, integration of communication, sensing, and localization technology in a better way. So for that reason, in our 6 different research areas, we are working with these different aspects. So when it comes to making technology more green, we work on that with materials and the hardware, lots of things. We are working with things like distributed MIMO technology in order to have an infrastructure that might be more power efficient by dealing with interference better. And also, how can we orchestrate our network to turn off equipment when it's not needed in order to be more green? So it's sort of going from what hardware do we use, how do we deploy it, and finally, how do we operate it? And when it comes to trustworthiness, we both have up the application side that it's not about the peak rates, but rather what is the predictability that we can have? Can we guarantee latency? Can we guarantee data rate so that applications that have stringent requirement can rely on this type of thing? And also the robustness against different kind of disturbances becomes important both when there are actual attacks or just when someone is happen to interfere in a way that is not meant to be. And finally, the availability aspect is really important because 5G technology, if we just have base stations everywhere, well, we would have a great performance everywhere, but we don't have that. We have issues with the big variations in quality of service, and that is what we need to address. And cost efficiency of technology is, of course, an important part of this. So we are working with this in our different research areas. We are starting from what we are doing good today, and we are bringing in these new metrics and functionalities in all of our activities. So we therefore have this tagline: we want to realize sustainable, resilient, and fair wireless communication sense in a digitalized era. We have a website, which is kth.se/swewin. And this is how it looks like. And even if we are working specifically in Stockholm, there are things that could be of interest to other people. So we are organizing workshops quite frequently. So these are some things that we had since May. We had a workshop about near-field communication in collaboration with the people who came and visited us from Japan. We had in August a KTH Aachen workshop. Then in September, there were a Digital Futures KTH 6G Summit that we co-sponsored with some 100 people there. And then recently we had a workshop on AI in communication systems. So these are all physical events, but anyone who is actually come to Stockholm physically, much welcome to attend. And we're also putting out some of the slides afterward. In addition to that, We have just started our webinar series. We had one webinar about satellite communications a few weeks ago, I think it's 2 weeks ago, and then we will have on the 12th of November another seminar by Angeliki on unlocking the potential of near-field communication for perceptive wireless intelligence. So this is really about being a place where we are every month organize the seminars to bring in new knowledge, particularly then from the European region, because we are in the same episodes. So with that, I hope you have got an overview about what SWEWIN is doing, both in terms of its research visions and in terms of the outreach activities that we are doing. And please look for us also on LinkedIn and connect with us there, because then you will also get information about our webinars and things like that. Thank you.
Thank you, Emil, for the good presentation. We can then directly move on and giving the floor to Tommy Svensson, who is a professor at Chalmers, and he'll give an overview of the WITEC Competence Center.
Thank you. So, can you see my slides?
Yes, now also in presentation mode. Thank you.
Great. Thank you. So, thank you for organizing this event, and good afternoon to all. So my name is Tommy Svensson. I'm professor at Chalmers, leading wireless systems research. I will present the WITEC Research Center on behalf of the center coordinators, Mariana Ibarshina and co-director Christian Fager. So WITEC stands for Wireless Infrastructure Technology at Chalmers. And we have in total 18 partners from both telecom industry and different vertical sectors. So this, as I've been highlighted before, it's a 5+5 years program. So we hope to continue until 2033. And the vision of WITEC is to create a sustainable future by developing next generation or robust and trustworthy wireless communication and sensor systems rooted in the current 6G development, but also looking forward towards evolved 6G and further. And then also to develop sustainable and efficient and semiconductor components and processes. So we have 4 research lines. The first research line is focusing on digital signal processing techniques for future and vision convergence of wireless infrastructure services and global service coverage. So this, in particular, will look into different kind of distributed integrated sensing and communications approaches. And we do it from system perspective, and we do it from signal processing, and we do it from modeling on hardware constraints, and then joint optimization techniques. So in that research area, there are research line, there are 3 projects. In line 2, we focus on agile, sustainable, and efficient wireless hardware solutions to enable efficient resource sharing, utilization of new data, and reducing environmental impact. So a special focus here is on different kind of integrated embedded systems and circuits and reconfigurable antenna systems. In the research line 3, we focus on reliable semiconductor components, design processes, and autonomous test methods for trustworthy systems design and increase production efficiency. So focusing especially on packing and integration, in-house process development, and over-the-air testing using our antenna lab. And in research line 4, we focus on a unified ecosystem where we align priorities and coordination center-wide collaborations, training, and beyond. So this is a joint initiative then among all the projects, so it's called FAST. The organization of our center is like as follows. We have a general assembly, we have a steering board and advisory board supporting the steering board. We have the direct co-director coordinator and with admin support, and we have a management team. And the management team is then representing the 7 projects. And the acronyms of those are Discourse, Auto-OTA, Digi Arrays, Crite Plus, HiCom-In, Remu, and Suite. And then, as I mentioned, the first project. So there are 18 partners. We have 8 delegates in the steering board, and the chair is Maria Vagelius from ERCS. The advisory board, we have from international universities and institutes. So as you see, Christoph Meckenbroecker from TU Vienna, and Wolfgang Heinrich from Brown Institute, and Rihanna Geschke from Fraunhofer FHR, and Christophe Gaguier from the University of Lille in France. As I mentioned, director is Marina Ivashina, and the co-director is Christian Fager. And then we have 2 coordinators here helping the center, so Christian Andersson and Darina Pessina. And the management team is then composed of 11 professors, and you see the names here, so we are representing the different scientific research directions at Chalmers that are represented in this center. We do center-wide collaborations and training. One very important aspect here for this interaction with the local ecosystem in the west coast of Sweden. So Chalmers and the center is hosted Chalmers is in Gothenburg, and we host the center, and the main collaborators are then from the west side of Sweden. So here we have a focus on, and that's an advantage with the physical center. We can do physical mobility across industry and academia. So we do joint supervision of PhD students, or master students and bachelor students, where we have physical mobility then between industry and academia and vice versa. And we have a mentorship and gender balance program. So within the center, we have experimental infrastructure, widely gathered multidisciplinary competencies, world-class scientific infrastructures at the Chalmers and at the RISE, the Swedish Research Institute. In particular, we have access to the AstaZero automotive test track, which is one of the best in Europe on automotive testing, with the full built-out digital infrastructure. We have the terahertz antenna test chamber, which is a state-of-the-art chamber, top-notch in Europe. We have a clean room for chip fabrication that is also quite competitive Europe and worldwide in the capabilities, including nanoscience and quantum computing labs. So we are focusing on developing center-wide demo. So the short and mid-term impact goals are to do demonstrators for multidisciplinary research, training, and continuous feedback within WITEC projects. And the goal towards here, driven by the FAST project, is to demo a showcase at European Flagship Conference and Exhibition, the European Microwave Week, which hosts, we typically attract 5,000 participants or so. That will all be organized in Gothenburg 2028, with a lot of the WITEC consortium partners involved. So that is our big goal. The long-term impact goals are to develop demonstrators in a real live environment, installing a 5G plus 6G infrastructure at RISE, at AstaZero, and integrating objects from partners, for example, mobile base stations, users, cars, and UAVs, and including satellite networks. To demo then particular communication, localization, and sensing integrated in a mobile infrastructure. And we do cross-center demonstrators, for example, related to space and quantum. From the wider perspective, Vitec is complementing and leveraging on national programs. So in particular, the SSF Semiconductor System Design Center Classic and the Edge Computing, for example, the COSA. So you see some of the icons here, the logos. And we also then complementing on the Vinnova and CHIPS Act competence, the Wallenberg centers, and the public sector Västra Götaland region. We are also having far out international outreach in our collaborations. So recognize international lead and benchmark in wireless academic industrial collaboration. We have agreements with strategic suppliers, such as WinSemi, Henkel, and LPKF, and new partnerships through engagement in major EU and international research and training programs. So with the professors involved in the management team, we are very active in various European initiatives. Myself, been very active in HexX2, and we are involved in several EU projects within SNS JU. From a broad perspective, we have a long legacy here with this kind of competence centers rooted in antenna technologies. So also over 3 decades, we have been running this kind of competence centers at the Chalmers. The first one was initiated by Professor Erik Holberg, and that was on microwave technology. The name was Chalmers Center for High-Speed Technology, CHAC, and started in 1995. We had a long sequence of previous centers with this similar setup. They were called gigahertz on the hardware part, and chase or chase on the more system algorithm and system aspects. And that were and those were run from 2007 to 2021. So in the 5G era, we focused on transmitters, millimeter wave, and linearization hardware, and different kind of effects here on communication sensors and turrets, and then integrated antenna arrays, vehicle communication, and multi-antenna wireless architecture for 5G, sensor systems, and microwave hyperthermia. And that, I think, concludes my overview of the Vitec. So we are active on LinkedIn, so please follow us there. And we'll be around here for the Q&A later on, so I'm very happy to interact further with you.
Thank you very much, Tommy, for giving the overview of Vitec. Before moving into the last presentation, I'd like to remind everyone that we have a Q&A at the end of the session today. And if anyone already knows of any question you would like to ask, you might already want to put it in the chat so that the speakers could already think about it and prepare for the answer. But otherwise, you can also, of course, spontaneously ask questions in the Q&A, of course. So moving on, last presentation will be from Peter Almers, who is with Ericsson, and he will give an overview of ISAC, the Ericsson Sensing Testbed, and Advanced Digitalisation project. Peter, the floor is yours.
Thank you very much. Yes, I'm Peter Almers, working for Ericsson in Lund, south of Sweden, and since we started this last Christmas from the signal processing point of view, and we start to build the test network that I will show last fall. So it's pretty new and extremely exciting, if you ask me. So what you see the screen here, we have a number of nodes, commercial radio units, and this is what we actually use in the testbed in Lund. That was one of the prerequisites or wishes from Ericsson to see what we can do with commercial radios and discover all the problems that we have with them, for example, the antenna spacing and whatnot. So I will focus on this, and it's a mixture between communication and sensing, and try to find this little drone. Just some overhead of our path from left to right, some kind of timeline. We started with connecting everyone, build out the mobile internet and cloud networks. We are somewhere here now with, I think, 5G standalone, and network slicing is something that is very nice as a feature to support, for example, then the sensing that will come next, and which I will focus on today. So start with what it is, and sensing in 3GPP is integrated sensing and communication. So there is a share between of the resources that we have. So we're going to take some of the mobile broadband resources and use it for sensing. And how we split it will, of course, impact the performance of both communication and sensing. If we have 50% allocated for sensing, that will be better than if you have 10%. So yeah, as you see here, we have our radio nodes or our sites transmitting, both communicating with the UE here and also having a transmit signal, hopefully bouncing on this little drone, and received the echoes will be received on other nodes then. So we are looking at different ISAC modes, as we call them. We have the monostatic sensing, where we transmit and receive at the same time on the same radio. This is a bit challenging because we have a big leakage between the transmitter and the receive path. So this is somewhat similar to sub and full duplex or full duplex. But there are ways that we are looking at also on hardware prototypes for this. But what I will focus on today is this multistatic sensing. And that means that we have radio nodes on different sites, different geographical positions or locations. And we transmit from one and listen on other link ends. So this is the focus of today. And just some of the challenges that you always have, I guess, with radar, and especially in bistatic radars, is we try to put on this a little bit messy slide. But we have the transmitter to the left and the receiver to the right. And when we transmit the signal here, it will bounce off on lots of things. And most of the energy that we receive here is coming from unwanted signal, or clutter, as we call it, like static objects, reflections from the ground, reflections from buildings, or from some trees. And within this received signal, we need to figure out the small fraction of energy that is coming from, in this case, the drone. And then we also have, in case of, for example, line of sight between the transmitter and the receiver node, we have a strong signal hitting the receiver directly. And of course, we can tailor the transmit beamforming or null forming to try to support this, but it's still a challenge. This signal is very, very weak. There's not all bad having this direct line of sight or a static reflection that we can rely on. It's used for syncing the transmitter and the receiver, since we are interested in the absolute range. And it's also used for phase noise or phase compensation, since we have running on separated clocks and PLLs here and here. So we need to do something about the phase rotation. So the top level structure of what we do. We have the sensing and fusion. That's how we are separating the main functions. Each of these boxes contains a lot of signal processing boxes. But we start from the left. We have, for each receiver node, we have IQ data, or complex numbers, that we have received. So we have a multiple streams here, high data rates, which is somewhat of a problem. And then we do the sensing. And in the sensing, we do match filter, and we do all these compensations of phases and try to find out the true distance between the nodes. And we also do detections. So we detect the targets, and we estimate the targets in angle, elevation and azimuth, in range, and in speed. And then when we have the detection, the detections here has low bandwidth or data rate compared to the data that we get in the beginning of the link. So on the screen or on the plot here, you see you have X and Y representing some 2D location of the targets that we detect. And you can see there is very much jumping around here, coming from detections that this does not make sense. But you can see there are something that has some kind of correlation here. They make sense. They make like a track. If you see the dots where my pointer is. So what we do is we add a physical model. So we define how can the drone, in this case, move. So a drone cannot move from 1 second to a next second like 1,000 meters. That does not make sense. That doesn't map our physical model. So we add those physical model of the drones to this tracking and fusion engine here, the green one. And then you get this out. And this is what we call tracks. So you can see them, they are here. This is no cheating, they are here, and we get them out here. So the Lund test network setup. As I mentioned, we are using commercial radios. We are running on 3.85 gigahertz. We have a license here in Lund for using those frequencies. So we generate the signal in the baseband. We transmit it on a transmitter on one of the sites, and we receive it on a number of RX radios. Pass them through the baseband, so we're not actually doing any processing for this test setup. And all this IQ data, these raw complex numbers, are then processed on Dell servers here in Python, where we do the target detection, target estimation, and we actually do a sensor-based tracker and fusion. So we do that per link. We call this is one link, this is another link, just to reduce the number of targets. And finally, we do this system-based tracker. So we combine all the targets into one common track. And just to get a little bit of feeling for how far it is and how it looks like, here is the Ericsson building in Lund. Here's one of the sites. You can see it's we have mounted it on existing sites. Here's another one close to MaxLab 4. It's another site. And there are some other sites also not shown in this picture. And then it's approximately 2 kilometers between these two and 1 kilometer between those. And then for what I will show you, we fly a drone here where we log the GPS positions, and we use that as a ground truth. And I'm going to show you 2 videos now. I don't know how am I good in time? I guess I am. So I mean, this is pretty recent for us, but it's probably nice to show. And I heard both Tommy and Emil talked about sensing, and that makes me happy. So maybe you want to use our data for something. But here you can see to the left 6 plots here, they are this link level. So it's 1 TX and 1 RX. We have the PCIs or the IDs of the links of the radios here. And for each of those links, we actually do this tracking and fusion. I will show you also the detections, how it looks like for an extreme case. So that's that. And then we have the multi-static system tracks, where we try to put all those together to understand what we're doing. And you can see all the nodes here, the numbers. Here, this is a transmitter, this is a receiver, then this is a transmitter, this is a receiver, it's T and Rs. And you have the reversed link for all the links. You transmit in one direction, and then you receive in the reversed direction as well. So then we have confirmed tracks here. We have a little bit of tail to show what we have tracked in the history of the confirmed track. We have this blue little square here is just this one. We zoom in here just to get a little bit of zoomed in view. And you will also see that the only ground truth we have is the orange, the drone position. But you will see that there are cars coming on the E22, passing Lund here. This is north of Lund. And some cars going on Oderslövsvägen as well. We haven't, we don't have a ground truth here, but they are actually running on roads. And all the measurements that we see has not only, it's not 2D, it has 3D. It has a height as well. So start first with, if you add all the detections as well, you will see how it looks like. It's a bit messy. And this is what you can see the black ones on the left 6 plots. But then you do sensor space. Then we do this fusion tracking per link. And now we go to then when we have filtered, we don't show the detections that are the underlying measurements that we use for the tracking, and only shows the sensor space tracks and the system tracks here. Will that start?
Are you done, Peter?
Sorry?
Are you done?
No, I would like to show this. This is what I want
okay.
to show. This is my main movie. Why doesn't that show? Sorry for this. I need to do like this then. Give me one second. Why is this happening now? Maybe we can do like this instead. You have to skip all the black dots in this one, and then you can see, you can focus on this side here. Sorry for this. Sorry for this. And yeah, you can start to see, if you look at focus on the right side here, you see we are missing the drone here, but then we catch it again. And if it would have been a clean picture here, you will see that some of the links catch the drone and some is not. So I think this is what we see, and the precision is pretty good. And you can imagine how sensitive it is to having bearing errors on our mounting of the mounting of the sites, because if we convert this to a global coordinate system, and if the local estimates is done locally per radio node, so if bearings is of essence here, to put those radio nodes exactly in the direction that we think they are. Okay, yeah, sorry for that. Thank you.
Thank you, Peter. Certainly, I think one of the most interesting topics in my view in the current 6G research. So I think there's a lot of imagination of what you could do with this sensing. So thanks for giving some overview of what you are already doing on that topic. All right, before we start with the Q&A, I would like to invite Lena to give another view from her position.
Yes, thank you. Thank you. I just wanted to thank you, Emil and Tommy and Peter as well. And yeah, just to say that what we have heard illustrates some of the exciting and important work going on right now, taking place right now in Sweden within the 6G area. And from the perspective of advanced digitalization, we see both the importance of making industrial use of the latest available technology, and at the same time prepare for future possibilities for a competitive and sustainable industry. So yeah, thanks a lot. And I also want to just share, if you like to get in contact with Advanced Digitalisation, you're very welcome to do so at advanceddigitalisation.se. Yes, and now Ove.
Yeah.
Time for Q&A. Right.
Thanks, Lena, again. Yeah. So we now have a few minutes for questions. I looked in the chat. There were no questions in the chat, but is there any question any of the participants would like to ask? Any question from anyone? If there's none, at least at that stage, if I'm allowed, I would like to ask one, because I think first of all, thanks really to all speakers for this excellent presentation, which gave a very good overview of the Swedish program, and I think it's really impressive because it, in my view, it covers really everything from basic research over experimentation, trialing, test centers. Also, lots of focus on hardware aspects, semiconductors, etc., which I think is getting increased importance for Europe, and always with a close link to the industry. So I think, yeah, very impressive. But my question is, could you say what, in your view, is what is really going well in your program? What are the unique things, how you organize it, and what is being done? Maybe also in comparison what you know from national programs in other countries. So what is the specific thing about the program in Sweden? Is that possible to be summarized in a few words?
Yeah, if I start, I would say collaboration really between industry and the other areas. That's really focus of the program. Yeah, I think that's the main thing that we really need to actually get things to happen. Anyone who want to add something?
Okay, please,
please.
Okay, from Chalmers' perspective and the WITAC Research Center, I've been at Chalmers in I think more than 20 years in these kind of centers, and what I really appreciate is these physical collaborations that we have meetings in person quite frequently. We can have co-supervisors from industry to our PhD students, and we meet regularly across industry, academia, and cross sectors. So this local collaboration has a big value there, in particular from my perspective, since we also have a strong activity in the EU program. So we have the international perspective there, and are also for international and academic. But these are really hands-on, and with from our side that we have so strong hardware and component aspects means that we can see through the layers what are the bottlenecks, which I think are getting more and more important when you want to do. Really, 6G should be about do things very sustainable and efficient and trustworthy, and then the weakest point is what matters. So working cross layer is quite important, and I think we are well set for that.
Mm-hmm. Mm-hmm. Thank you.
Yeah, I also want to add basically to the same argument that these are programs where you are not working side by side, but you actually are working together, and the people in the companies who wants to be involved in these kind of activities are also the ones who really wants to come and give feedback to what we are doing, and also having a good understanding of that we are approaching topics and should approach the same topic from different perspectives. They have taken a PhD, many of them in academia, maybe in Sweden, and give input to steer us in academia in the right direction, but also let us do what is our best activities, which is digging more into the fundamentals and improving results and things like that. And then also the long-term perspective of these competence centers is really important, because when you get started with projects that involves many partners, then it could be a lot of effort to get all the paperwork together. But once you have done a 10-year program where you have the paperwork in the beginning, you can be much more reactive to things along the way.
Yeah. Collaboration, indeed, that's really crucial, and being open for comments. Yeah. Okay, I see we have a raised hand from Franz Dielacher. That means you have a question, Franz. Is it correct? Franz, you are still muted in case you want to ask something.
So maybe now you can hear me, hopefully.
Yes, yes,
Yeah,
yes.
question
Now.
may be somehow related to all the three presentations or speakers respectively. Namely, somehow, or maybe I missed something. I definitely did not hear something in the direction new frequency bands. You know, there is a lot of discussion about these FR3 frequency bands when it comes to 6G, and that somehow was not really mentioned in your presentations here. And is there also a focus in this context in your programs here?
Anyone wants to answer to that?
Okay, I can start if they are muted. I don't know about the programs, but just from this sensing that I failed to show is that we are of course looking. We were here running on 3.85 gigahertz, and different frequencies from an ISAC point of view see different things. And we are building out this Lund test network with other bands as well, and the fusion parts is agnostic to what we see. I mean, we detect something, we estimate it, and then we can fuse it. And I think that is this redundancy. The reflections of orbit is very different and frequency dependent. So I think this for us is an important next step to start to mix bands from a sensing perspective and sensing performance perspective as well.
Thank you.
I can comment from a Vitec perspective. We have been always looking on quite broadly on the frequency ranges, especially on the transceiver hardware parts and components. Given that we also have a strong track record on wireless, micro radio transmission links in the Gothenburg region. So we are pushing the frequency up to sub-terahertz, a couple of hundred gigahertz transceivers for wireless backhauling. And then we have the roots in mobile communications access and self backhauling, where we focus on centimeter wave, and then in this 6G era now, the FR3 candidate bands up to 15 gigahertz or so. And there we, in particular in the Discourse project, we also look into multi-band communications and integrated sensing and communications, where we're combining both FR3 candidate bands with the FR2 legacy bands. So yes, we are looking into all of those things in Vitec.
Thank you.
I could mention also that one of the things that we started with doing was exploring as a MIMO researcher, what does the MIMO technology from 5G in the 3.5 band potentially turn into? And we are calling this gigantic MIMO, and we have a publication and some videos about that as well. If you search on that topic, you can find this, but this is something we did within the Sweden.
And I don't know, Emil, if you are, from an implementation point of view, we struggle a bit with many antennas to make it cost efficient, and we have different levels of beamforming to try to handle that. And I guess maybe that is also something you're looking at.
Yes, to some extent, we are working with Puja and Son and others discussing those kind of aspects.
Yep.
Thank you. Are there any further questions? That seems not the case.
Yeah, it's still
okay.
again me.
Yeah, sure,
and
please.
Maybe a special question to Peter. Namely, when we say your focus was on this sensor space tracker and fusion, is this somehow, let's say, related to, in the car context, we are talking about sensor fusion since a long time already. is there some cross connection to what you have to do when you talk about sensor fusion in cars?
Anybody wants to answer?
I should probably answer.
The
Do you
comment
hear me?
was to repeat first.
Just first, do you see my nice video now?
We see the screen, but just the WebEx and the people. But,
I can have it on when I talk, I was thinking. So now you also have the drone video here. That's nice. Okay, yeah, I think, I mean, there is lots of history done in radar. I mean, there's nothing new, but there are implications when we start to mix this sensing and communication. It's coming from how we should schedule things, how we will, the interference that we will experience, how much of what kind of coverage do we have for sensing? Because it's completely different to have an active transmitter like a UE. Here's everything is passive. So there are a lot of old stuff that we are reusing, but there are also new things to discover from an ISAC point of view, I think. I don't know. Did I answer your question?
Yeah, thank you.
Yeah.
Anyway, thank you to all of you for these nice presentations, for this nice overview. Thank you.
Thank you. Peter, you're still sharing your screen. Just
you know. I was thinking I should do that.
So I can also comment a bit on this question from White Center perspective. Since we have Volvo Cars on board and some other automotive players, we also see this bigger picture where particularly the automotive sector needs to know what they're doing. So that's a sweet spot, I think, in the end on how are we collecting information and how are we sharing it and who is under control it and who are making the final decisions on how to use the information. And that is, and what are the business models around this also. So I think there are still quite interesting things to be done, and this is, in my view, the next step in Cellular V2X, where we add this kind of sensing in a very integrated way. So many exciting questions, and we try to look into them.
Thank you.
And I also think there is lots of discussions on what kind of requirements are we looking for. I mean, are we building a Saab radar, or this is early warning radars? And when we have been on conferences with, for example, Ukraine researchers, and also I think Saab is changing from doing something, a few super duper radars, to actually have a massive, cheaper radars for lots of reasons. So I think there's a turn in the industry as well. And when you go for something less dedicated for radar, I think there are new things that we need to consider that we cannot take for granted in terms of impairments in our systems or in cheaper systems as ours.
Yeah. In one of our, a few of our projects in White Tech, we also have Saab involved, and we have this kind of discussions on similarities and differences in the CAD systems, both the conditions on how to build them and how to deploy them and how they've been operated under what conditions. So try to identify common academic research questions that have value in both the civil and in the military or dual use direction.
All right. Any final question? We have time for one more question before we close. Is there any further thing anybody wants to know? No. Okay. Then let's close for now. Yeah, first of all, thanks to all the speakers. I think we got a very good overview of the Swedish 6G program. Very interesting. Thanks also to the audience for your interest. And in case you want to revisit again any of the presentation or even watch again the full webinar, we will upload the slides and also the video to the event webpage, which would be available shortly. So just look at the page again in order to to have the chance to again download the documents and watch the video. And then, yeah, we hope to see you again in one of our future webinars that we will organize with national initiatives. Thanks everyone for your time, and have a good time until then. Bye bye.
Thank you. Bye bye.
Bye.
Thank you.